Integrated 1 students. This is section 2.6, mean, median, and mode. This is definitely, as we come out of a quiz, probably, and that was even, so before this quiz we probably took, we were doing solving equations, like getting x by itself, so I would definitely call this a change of gears, and so kind of a very different topic than solving for x for sure. But this should be very familiar, right? This whole mean, median, mode, maybe get into range also. These are some very important, big-time vocabulary words, and so the mean is another word for average. So the mean is the same as average, right? Kind of like the normal, expected, like if you had to describe a whole list of numbers just by one number, like one number to represent a whole group of numbers, that might be a way to think about the average, and doing the average of 7, 8, 4, 5, 8, 9, 5, and 5. Okay, what we're going to basically do is, and this is how you find the average or the mean all the time, you add up all of the numbers in the data set, and then you divide by how many numbers there were. So the sum of all numbers divided by how many numbers total. So in this case, this would be 7 plus 8 plus 4 plus 5 plus 8 plus 9 plus 5 plus 5. And we divide by, let's see, 1, 2, 3, 4, 5, 6, 7, 8 total numbers. Where's my calculator? So 7 plus 8 plus 4 plus 5 plus 8 plus 9 plus 5 plus 5, I get 51. And then we're dividing by 8 to get exactly 6.375. So let's say this was like a bunch of basketball games where someone scored 7 points, and then another game they scored 8 points, and then 4 points, and then 5 points, and then 8, and then 9, and then 5, and then 5 points, like in 8 different games. You could say their average is 6.375 points a game, so you could expect them to score between 6 or 7 points on any given game, I suppose. And now next we have median. So what is the median of a list of numbers? Okay. Well, where in life outside of mathematics does the term median come up? Did you know that there was medians on a lot of busy roads or highways? So where is the median on a road or highway? Isn't it in the middle? So that helps you remember that the median is the middle number. But they have, the numbers have to be in numerical order, or just in order. Okay? And then once they're in order, you figure out which number is in the middle. So they got to be in order. So let's see, we would go 4 and then 3 5s in a row. And then it looks like there's a 7. And then it looks like there's a couple of 8s. And then a 9. So going in the middle, I mean, some people do this rainbow gimmick where you kind of work from the outside in. You know what I mean? Until you get to the middle. But for me, most of the time, it really just boils down to there's 1, 2, 3, 4, 5, 6, 7, 8 numbers. Still, okay, the same 8 numbers. And if there's 8 numbers, wouldn't the middle be between like the first 4 numbers and then the second 4 numbers? And so wouldn't we be going like in between the 5 and the 7? Like that's where the middle is. You have to go between the 5 and the 7 to be in the middle, because that breaks it up into 2 halves of like 4 numbers each. You know, there was 8 numbers total. And so when this happens, when you go in between the 5 and the 7, what you're basically doing is finding the average of 5 and 7, which would mean you might have to do 5 plus 7 and then divide by 2 to find the literal average of 5 and 7. But sometimes it's just like, okay, what number is in the middle of 5 and 7? And you can just kind of do it in your head and say that it's 6. All right? So that's what happens there. But what if, let's say, what if I added, like, say, like a 9th number, 13? What would you do, right? Now it looks like if I worked from the outside in, right, like boom, 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 and then these 2, and then these 2. And so with a 9th number in the data set, it looks like the number that's in the middle is one of the actual numbers, the 7 here, this 7. Because now that makes that there's like 4 numbers over here and 4 numbers over here and like a number here. So in conclusion, sometimes the median is one of the numbers, and sometimes the median you have to go like in between 2 numbers that are like in the middle. And look, it's not rocket science to figure out when each one happens. If there's an odd number of values, you're going to have this kind of situation. And if there's an even number of values, you're going to have this situation. Another median example, well, I guess we have to, this looks like the same exact data set, except they're not adding in a 13. It looks like they added in like a 2. Yeah, because there's the 3 5s. I know your game. And then a couple of 8s. And oh my gosh, I had a feeling something was not right. Ha ha ha. That's why you got to be careful here, people. I would have caught that eventually, if not right away, like I did. And so, I mean, I'm just so you know, I mean, like I'm right up on the screen here. It's not like I have like a full, you know, zooming out picture, you know, like if I'm looking down at a piece of paper. Like it's not easy to see everything when I'm right up at the board. Anyway, so this is that situation where, and you know what, I'll show you this whole rainbow gimmick. You might have been taught this way, kind of like working from the outside in and going like, oh, looks like here 5 would be the median, right? There's an odd number of values, and so this would be the middle number, like one of the actual numbers, and it'd be 5. Now the mode is the number that occurs the most, which it's kind of convenient how the word median sounds at least kind of like the word middle. Median, middle, and then mode sounds at least a little bit like the word most. So mode is the most, median's in the middle, and mean is the average. Those two words sound alike, right? Maybe not so much. But median's in the middle, mode is the most. And so it looks like it's the same data set. And so with a score of 3 times versus 2 times, so it looks like the mode is 5 because it occurred 3 times, the most times. And a couple quick follow-up questions to elaborate a little bit. Is it possible for a data set to not even have a mode? Like, what if every number just occurred once? Would there be a mode? Would there be like a 8-way tie or a 20-way tie? Or would there just not be a mode at all? Like, again, if you had a data set where every number just occurred once, would there even be a mode? And the answer is no. So sometimes there is not a mode. Sometimes there's no mode. Now, what if there was like what if there was 3 5s, and what if there was like a third occurrence of the 8? Would there not be a mode? Would there be 2 modes? What would be the case? And the case would be that there would be 2 modes. You'd have a mode of 5 and you'd also have a mode of 8. But I don't think that's ever going to happen to you. I guess I can't really say for sure, but it's way more likely that you're going to have a mode, you're going to have 1 mode, and that's it. Not 0 modes or a 3-way tie, just 1 mode. Okay, the range. Well, in layman's terms, the range of the data, like, is how much the data, like, spans. Like, I know that's just a synonym, but what's the span of the data, you know? Well, in math terms, it's the highest, or, oh my goodness, or the highest value. All right, this is not happening now with this pen and board. The highest value minus the lowest value. Or in other words, the difference between the highest number and the lowest number. You know, and that'll give you, like, you know, think of like the range, like the numbers range from what to what, or like what's the range of a bow and arrow, or what's the range of a gun, or what's the range of someone's throwing arm in baseball or something. You know, like the numbers. So in this case, the numbers range from 4 to 9. From 4 to 9. The range is from 4 to 9. Like, that's what the span, like all the numbers are in between that. And so what we would do is 9, oh my gosh, getting ahead of myself in my own head, but it should be the highest number minus 4, the lowest number. And so it looks like the range is 5. All right, here is where you would probably be instructed to pause the video like in class. I hope we kind of, like, you try. So pause the video, please, and see if you can get these answers on your own before you see what I get. Okay, so pause the video now. All right, so for the mean, I'm just going to do it on my calculator. 95 plus 79 plus 82 plus 77 plus 98 plus 99. Oh my gosh. Please keep track whenever you do this. It's like it's a lot of presses of buttons. So just please be careful and focus and you don't hit a button or something or hit the wrong button. Oh my gosh, where am I at? Where am I at? Plus, oh my gosh, plus 92, plus 92, plus 85, plus 79, plus 93. And for the sum, it looks like I'm getting 879, and then I'm going to divide by how many there were. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let me just double check this. I don't want to be wrong. 95 plus 79 plus 82 plus 77 plus 98 plus 99 plus 92 plus 85 plus 79 plus 93, 879. So that's what we'll go with. Guess what? I'm so smart. I don't even need a calculator to divide by 10. It's going to be 87.9 is the mean. Now for the median, we're going to have to put these in order. Oh gosh. What's the smallest one? Is it 77? Just double checking. 77. And then it looks like a couple of 79s. Is that right? Looks right. And then what? Then what? Then what? Then what? Then what? Okay, so there's no more 70s, right? Okay, so the 80s. 82? 82, 82. Yes. Why am I so nervous? 82, and then 85, and then 92, I hope, and then 93, and then it looks like 95, and then we're going to finish off with 98 and 99, people. Okay, so doing it my way, what was there, 10 numbers? So it looks like the middle, it looks like there's going to be like an even Steven split of 5 and 5 to get to the middle. 1, 2, 3, 4, 5. And then right here, and then, so let's kind of, 1, 2, 3, 4, yep. Looks like our middle is going to be in between the 85 and the 92. Now, I think I know what that middle is, but I'm going to follow my own advice. And when in doubt, check the actual average or mean. 85 plus 92 is 177. And then we divide by 2, and so the median turns out to be 88.5. Now the mode, that should be a little simpler of a task. Are there any repeats? Looks like the only repeat at all is a couple instances of 79. Well, there we go. 2 to 1 to 1 to 1 to 1 to 1 to 1 or whatever. So 79. And the range. The range is ranging from 77 to 99. So we just do a quick little subtraction. 99 minus 77. And I'm going to go out on a limb and just say in my head, but check a calculator if you have to. The range is 22. I don't know about you, but I'm feeling 22. Now for an outlier. What the heck is an outlier? Maybe something that lies out of something. I mean, it's a pretty good name. Outlier, because yeah, it's going to be a number that in a way doesn't belong. You know, it lies outside of what the other numbers sort of are. And yeah, it's a number that doesn't belong. It doesn't seem to fit with the rest of the numbers because it's way too big or way too small compared to all the others. Now, I think my classic example, this is always my go-to example, at least in like the year 2018 and leading up to now. My classic example is thinking about all of the salaries of the employees of Microsoft, or at least Microsoft back in the day. I don't know what Bill Gates does these days, or if there's other main executives or presidents or whatever of Microsoft that get all the big bucks these days. I assume Bill Gates still rakes in a lot of money, even if he's like retired or whatever. But anyway, let's just say old school Microsoft, and if you put together a comprehensive list of all of the employees of Microsoft, or at least a pretty good slice or representation, certain percentage of all different kinds of employees at Microsoft, from the secretaries to the programmers to the administrators, whatever. I'm sure there's all different kinds of people that work for Microsoft, and you listed all their salaries, and then you included in that list the salary of Bill Gates. In a list of Microsoft salaries, or geez, you know what? Just a pretty representative list of like all kinds of salaries, even doctors, teachers, policemen, whatever. Just like any list of salaries that kind of covers like the normal population. And then you threw in Bill Gates' annual salary. I mean, my goodness, man. Especially on like a smaller list, you would have this list. Let's say you had the list without Bill Gates' salary on there, and you took the average of that, and then you threw Bill Gates' into the mix, and then you took the average again. Bill Gates' one salary would probably like bump up the average significantly to be more. You look at Bill Gates' salary and be like, this salary doesn't belong with the rest of them. It's like $1 billion compared to like, $40,000, $60,000, $100,000. I don't know what the average would be across the country, without the likes of like Bill Gates. But anyway, that'd be like an outlier, And you could also have outliers that are like way too small to, I guess if you took, I'm kind of making this up. This is all kind of like pretend, but let's say all of like the NBA salaries. Like let's say you took like just sort of a random survey of NBA salaries, and they're pretty much all in the millions, I would think, or at least hundreds of thousands of dollars. And let's say there was just some like random player that for whatever reason was only making like $20,000. That would be an outlier because it'd be like a little too low to fit in with all the other ones. It would mess with the average in an unfair way. Like if you wanted like a true average, here's one way to say it before we move on. And I don't know if I'm like taking liberties with my with this, but I'm kind of like, I don't know, like not giving like legit mathematics, but if you wanted to do like a legit average of the salaries of people at Microsoft, you probably wouldn't include Bill Gates' salary in there because it would like unfairly affect the average. It would give you a misleading average. You know what I'm saying? Like, how about this for an example? This might be a better example. Let's say you were a basketball player in the NBA and you scored like 10 points, 9 points, 11 points, 5 points, 12 points, and then one game you like just set the record or something, and you scored like 100 points. Wouldn't that like affect the average in an unfair way, and it would kind of give a misleading average because maybe you got like lucky one game and scored 100 points? Anyway, I hope you understand, because I'm just going to move on at this point and stop rambling. Okay, here we go. Find the test score for test 5 that would give Jake an average of 90, you know. So if we were to have some 5th test score and then take the average, we would want it to equal 90. So what would be like this mystery test number 5 score? We'll call it X. We'll give it a variable. You know, so here's what we do. We set it up like this. 83 plus 84 plus 100 plus 98 plus I don't know. But whatever it is, it's going to be added in there, and then we're going to divide by 5, because we're going to be, I don't know what test number 5 is yet, but we're going to add them all together and then divide by 5, okay? And that is supposed to equal 90. Alrighty? And this is where we start to work backwards, because when you set up an equation and solve for x, you're just kind of like doing these steps backwards. You're working backwards. You might be intelligent enough and you might understand average well enough to just naturally do this in your head, like work these steps backwards and kind of know what to do next. But I'm going to add these 4 numbers together, and I believe I'm getting, let me double check, 365. Oh, what am I doing? I knew it. I forgot the old plus x. Sorry. And now I just want to keep solving for x. And here's what you would do next. On your way to getting x by itself and doing these steps to find an average like backwards in reverse, we would multiply both sides by 5. That's the next step. Multiply both sides by 5 to make, sort of like cancel out that 5. And so I'm going to go off on the left here. What you get is 365 plus x equals 450, because 90 times 5 is 450. Now, what's the only thing left to do, equation-wise, to get x by itself? That's right. Subtract 365 from both sides. And you would get, I'm just going to double check on my calculator, 450 minus 365. You get, come on, pen and board. You get 85. So your mysterious x value to make all this work with like doing the mathematics for finding an average, right? Adding all the scores together, including the one you don't know, and then divide by the number of tests there were. That's supposed to equal the average of 90. And it turns out that x equals 85. So the final answer is 85. Let's do a couple more of these, okay? Let x be an unknown value in the data set. Find what it should equal in order to get the final answer of 5. Well, again, we do 4 plus 5 plus 5 plus 6 plus x, right? We're going to add them all together, even the one we don't know, and then we're going to be dividing by 5. 1, 2, 3, 4, 5. And that is supposed to equal 5. So I'm going to do this. 4 plus 5 plus 5 plus 6. This is going to be 20. I'm pretty sure. So the 4 plus 5 plus 5 plus 6, that's going to be the 20. And now what I'm going to do to solve for x and work backwards and get x by itself is multiply both sides by 5 in order to undo that 5. Okay, so now I'm just left with 20 plus x on the left. On the right side I got 25. And then the last thing in order to get x by itself would probably be to subtract 20 from both sides and get x equals 5. So this mystery number would be 5 in order to make this our final average. So x is 5. Another one. How many more are we going to do of this? Holy moly, we're going to really try to make sure you understand these steps, eh? But it's going to be the same steps over and over again. So this list of 1, 2, 3, 4, 5, 6 numbers, we just don't know the sixth number, but we do know the final answer is supposed to be 30 for the mean. We just got to figure out what x is. So 28 plus 29 plus 29 plus 35 plus 39 plus x, all divided by 6. There's 6 of them. That's all supposed to equal an average, a mean of 30. So again, this is the same steps over and over again. Feel free to pause the video and do these other examples before unpausing and see what I got. In fact, that's what you should do. Pause the video and finish the rest of these examples off. But I'm going to continue. 28 plus 29 plus another 29 plus a 35 plus a 39. 28, 29, 29, 35, 39. That's going to be 160, I think. We still have the plus x, and we still have divided by 6. And so the next step is to get rid of this by multiplying both sides by 6 to cancel out that 6. So we're left with 160 plus x on the left side. And over here, this would become 180. And now we subtract 160 from both sides to get x completely by itself. And so it turns out that my mysterious x value would be 20. Same thing, you might want to try this on your own before unpausing and seeing what I get. Oh my goodness. Let's just do all of these on my calculator, for crying out loud. 1 plus 1 plus 1 plus 1 plus 2 plus 2 plus 3 plus 3 plus 5. So 19 plus the x. So when you add everything together that you can, you still have 19 plus whatever that would be, all over what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 total numbers that you would divide by to end up with a final average, a mean of 2. So what do we do next? We want to get that out of there in our quest to get x all by itself on the left side. So we multiply both sides by 10. And so we get 19 plus x equals 20. And then we must subtract 19 from both sides to get x all by itself. And the final answer is 1. There you go.